Hey everyone, welcome to Devs in the Sheds. No sheds this week actually, so we're in travel actually. I'm in the Brisbane office. It's actually very sunny outside, but you can't tell in this meeting room. Paul and Aaron, where are you guys at the moment?
We're actually in Sydney today, so we're doing some internal video recording, and yeah, we're right next to each other at the moment.
Very cool.
It's still kind of overcast here, though it does look like there's some a good amount of light coming from in behind us. It's a reasonable day, but it's not as sunny as I'm sure it is up there for you, Matt.
Yeah, no, it's pretty excellent up here. Where's everyone joining from? Let us know on the chat. I'm sure we'll have a couple of regulars from America. Sometimes we get some people from Brazil, other Australians that are on their lunch break rather than the evening time. Let us know where you're from. In terms of people that are new to the stream, Devs in the Sheds is effectively about us usually being in our sheds. We like to be hands-on with the tools that we've got in our workshop sections of the sheds. We like to play with IT devices. We like to do a lot of coding. Aaron and Paul are both senior and principal solution architects within AWS, and I'm one of the technical account managers at AWS, and we're all normally based in Melbourne when we're not traveling. So, a pleasure to meet everyone that's joining in for the very first time. Today's episode is going to be about continuing the chatbot that we've worked on in previous weeks. So every so often we'll continue our little swag chatbot builds. This week, we've built a few intents, we've built a few products that you can take from the chatbot in previous weeks. Actually, Aaron or Paul, do you want to put the link in for the previous weeks, and just in case people want to kind of like go back and watch the original videos? But this week's all front end, and so I believe Aaron said something about React. Is that what you're building the front end with?
Yeah, I will. No, I'll go here. All right. Yeah, so I'm going to take a look at what am I going to do? So yes, it's going to be a React app. I favor React when it comes to web app development, just because it's very simple and easy to pick up, and it's not bloated and it's not a bloated heavy framework. So it's very small and easy to get into. I'm sure there will be many people in the audience who may disagree and have their favored libraries. And I do say library because React is not a framework, it's a library. But I don't want to start arguments with the rest of the people on the channel. So I will be starting with React. What I thought I'd do is I'd take a bit of a different angle perspective and take a look at something that I developed last year around a Lexbot front end. And then what I want to do is so start developing. So we'll do it live as we go along. Start taking bits of that out, and I've already put sort of the main sort of npx create React app scaffold together so that we don't have to sit and wait for all the libraries to install. But I want to take a look at exactly what are the components that we need from the front end to then talk with our Lexbot in the back end. And for now, it's not connected to our or for what I've done so far, is not connected to our Swaginator bot. But what we'll do is in the next episode, or the subsequent episode that we continue this project, we'll then look at taking what we're building now and then integrating it with the existing bot, just to show how we can separate the front-end application development from the back-end bot development, and then integrate the two later, and then understand what's required. But as we do that, I also want to take a bit of a look at some more complex concepts around conversational design or conversational functional design, as opposed to just as we've been talking and as we've been demonstrating. So when Matt's been building the bot, we have that little test and we can put in some text and hit send and wait for a response. That's just obviously send and respond, right? So when we get into conversational design, we can actually get into points where let's just say it were voice activated, right? Or we can add, audio, so we can have, it may be text in but audio out, or whatever way you want to interact in terms of a conversation with the Lexbot. Conversational design starts to get into more states. Instead of just send and receive, it's now wait and listen and translate or respond and speaking, and then going back to listening. So it's transitioning through states functionally on the front end, which are then used to send off a request to the bot, we can even look at eliciting a response without actually sending a text request. So you can actually trigger. So as an example, in a common scenario in a bot in Lex, right, is when you first get to the bot, you may not want to have to say anything, right? But you want the bot to actually come in and say, "Hi, welcome. How can I help you?" And the way that we do that is we initialize the connection with the bot by eliciting the introduction intent, so that the introduction intent doesn't actually have an utterance that's required, but it does have a response that we want to display in the chatbot. So we can look at how do we elicit or trigger a intent, and then get the response, and then we can continue on through different states of design. So what I think I'll do, if you can share my screen, Matt or Paul, now that I'm only operating on one screen, I can't jump between.
That's okay. Well, I was going to say we could go straight into this now, or if we wanted to very briefly cover a couple of the cool announcements from this week.
Yeah, that's a good idea. Let's do that.
Yep. So I'll share my screen very quickly because, as you all know, Aaron is migrating across to Mac. So he's still going to have his Windows laptop, but he's also got a Mac laptop for work as well. So he was taking photos last night of his new nice shiny M1 Pro Ultra Elite. Yep.
That was about 4:30 a.m. this morning at Melbourne Airport, I think.
Yeah. So he's very excited about his new laptop, but I also know the Alien with the graphics card's going to be, it's not replaceable for gaming. So tying these two conversations together, AWS has also announced as of last week that you can now use M1 Max in the cloud, which is very, very cool. So if you're an app developer, you're building a iOS application and you want a build server, this is kind of like going to be perfect for it. You could have your code pushed to a code repo, and then you can have like a CI/CD pipeline that then goes and does a build, produces an IPA, does all the code signing and all of that on the Mac instances in the cloud. So that saves your laptop from having to do this process. So if you've got an older Mac, or you just don't want to get your Mac tied up in that process, you can move that off to clouds. The other benefit of it is I do know they are a little pricey for this, but I do know that actually they are 60% better price performance over the other ECTelu Intel ones. So actually that's really good. But I do know that a lot of people were doing VNC into this, and they had like specific versions of Xcode that they had. You can always use XC version locally on your machine, but some people kind of wanted to have like an image of an older version of Mac OS running an older version of Xcode for iOS development, and the VNC, and then work remotely and use it as kind of like a remote desktop as well, in a sense. So that is number one. Number two that I might jump to is Repost. If anyone has used Repost before, it's a really good spot where you can search for problems that you're having on AWS. There'll be articles, around people that have solved these problems in the past. Repost was announced, I think it was 1 or 2 reinvents ago, but it's actually been used in AWS internally for a lot longer than that. So this was actually the portal that we originally would go to, considering we've got 300 services, and we'd find out, hey, okay, a customer's asking about this unique use case, we haven't seen that before, and then usually we'd find an article there that will kind of help us move forward. And then we also could have chats with SMEs as well on that were part of like the field communities in AWS that are focused on particular services. So Repost is building out for profile support, profile picture support, which is pretty cool. A very simple thing, but I think I just wanted to kind of call out how handy Repost is if you're building for cloud to get answers. So definitely sign up and use it. CloudFront has increased header names of up to 1,024 characters. That's going to be handy for specific use cases that you might have when you're relying on a CloudFront distribution. So that's just like a nice quick win for some customers. And then DevOps Guru has an log anomaly detection. So we covered DevOps Guru a week or two ago. So you can see that we're expanding that service as well, which is really nice to see. DevOps Guru does give you a really nice view of your environment state and things that change in that environment state, and you can have alerts and alarms set up. It's using machine learning in the background. It's a really good supplement to exact alarming. So you might go, hey, on the EC2, I want to monitor my CPU, I might want to monitor memory, I might want to monitor these things. I might feed that to Splunk or some other system, or I might just be monitoring with CloudWatch logs. But sometimes on specific workloads, there's a unique thing that's going to be important to that workload. And DevOps Guru is kind of like almost like an extra safety catch, so that if something does go wrong, it goes, hey, normally this app's running in, with these metrics, and then suddenly we're seeing this change. Maybe you should have a look at this. So it's really good for discovering issues.
The good thing about this release is that it's starting to take more advantage of your application as well. Because if you're, in the previous iterations of DevOps Guru, it was looking specifically at like what was coming off the back of, say, for argument's sake, API gateway, or whether or not DynamoDB was throttling, very tied heavily to AWS services. Whereas this now is starting to look for keywords in CloudWatch logs. As you know, you can push anything to CloudWatch logs there. So you can, push whatever you want out of your application there, and it will start taking advantage of like what you are pushing to CloudWatch for your application. So even if your application starts to throw like exceptions or errors all over the place, it'll start looking through those logs and start making its own determinations whether your application is incurring some sort of incident, rather than the application itself. Like your application might be seem to be working just fine, and the infrastructure is working just fine. If the application's not working well, and that could be, I don't know, a bad deployment or configuration or something like that. So yeah, that's an exciting one, Matt.
Yeah, that's it. So just a few quick ones, because I know that everyone's probably eager to get into this React front end. Aaron, are you ready for me to pass over to you for screen sharing?
Yeah, please do. I've got my little demo up on the screen if you want to just push it up. Yeah. Okay. So
yep, here we go.
What I wanted to just demonstrate. So this is in no way related to our Swaginator bot. So we're not going to get this complex in terms of UI or interaction with the Lex bot at this stage. If you, the audience, decide that you want to see like transcribe, you want to see poly, you want to see other services integrated with Lex, we can obviously jump into that. But for this Lex bot discussion, what I really want to look at is just the text box integration here. So this little demo that I've got running locally, I'm gonna reload this page. You can see the waveform. You won't be able to hear it obviously because I don't have my sound connected through to my microphone. But you saw the waveform, right? You can see here in the text box, it says, what is your command? So that's exactly what I was talking about a few moments ago around eliciting a response from the chatbot without actually sending any text to generate that response. So that's what we call eliciting a what are they called? Intent. So it's elicit an intent. And this is the intro intent. So basically this bot is just saying, hey, what is your command? I might say, my name is Aaron, and I've sent that off to the text to the chatbot, and at this stage, okay, there we go. So it has recognized that it knows my name. It's asking me, where do I live? Well, at the moment I live in Victoria, so I'm going to Victoria. So now what I'm actually demonstrating here is conversational flow, because it's waiting for a response.
Mm-hmm.
And postcode, let's just say in the city.
Actually, could you zoom in a little bit? I can read it, but I've noticed that the colors are a little bit dark, so I'm just thinking that might make it easier for people to... Yeah, there we go.
Yeah, so what would you like me to remember? Would you like me to remember your details? Yes, I do. All right, so now I'm not going to get into the specific details of what's happening in this chatbot in the background, but what I want to demonstrate to you here is I've just had a conversation. It's a very simple conversation, backwards and forwards, which is filling data slots. And then essentially the would you like me to remember your details is extending that by then storing it in an offline profile. So in this case, it's using DynamoDB to store all those responses. So So when I come back, it can remember my details. I wrote this a year ago, so I'm not sure if I actually have this section of it set up. Oh, there we go. Your name is Aaron. So yes, it's now able to go and pull the details that it's previously stored, and then when I ask it, so what's my name, it tells me my name. So the important thing that I want to demonstrate here is not so much the complexity of storing offline profile and all that sort of stuff, but building on what Matt was taking us through in the last session around creating those intents with our what do we call them, utterances. So in this case, my utterance is, my name is Aaron, which is actually the response. What is your command? Sorry, is the trigger for a elicit intent, which then a follow-up intent for that, because it has multiple data slots. It now wants to fill, what's the state, what's the postcode, and do you want me to remember? So it will continue to ask additional questions until it's filled out all of the data slots. Now, if I had said, my name is Aaron, I live in Victoria at 3000, it would have just defaulted back to, would you like me to remember your details? And so this is in line with what Matt was taking us through around, I want to order a extra large men's black shirt. And then that's filled all the data slots, because now we know the size, we know the gender, we know the color, and we don't actually have to go through and elicit additional responses from the user. So the bot doesn't have to elicit additional responses from the user to fill that data that it's looking for. So this is what we call conversational design, right? Now, what I was saying before is that there's two ways of handling this. In a very, very simple way, we can allow Lex to handle all of the understanding of each utterance. So if we're fulfilling a data slot in the existing intent, then Lex will know, okay, the response that I'm handing back relates to the data slot that I'm filling in, or it may be smart enough to figure out, well, you've changed the context. You're now saying something else that might jump. You might use that utterance to jump to another intent, right? But when we're going through conversational design, if we're in the background, you might have seen the waveform visualizer, running in the background. I can hear a voice that's saying everything that's in red is being spoken to me. Now, technically, if I wanted to, I could hit the microphone button and I could speak back, but then I'd have to go and use transcribe, and then it would send it to Lex, and there's a whole lot of complexity around that. But in doing that, we need to understand the state at which we're at inside the conversation from the front end sometimes. Not always just hand it off to Lex and say, all right, I'm going to send you an utterance, and you figure out whether it's a new intent or whether it's filling a data slot in an existing intent because you've elicited a request to the customer. So hopefully throwing all that out at you isn't confusing you, because if it is confusing you, you're going to get a whole lot more confused now, because I want to actually quickly just step into the actual source for that little demo that we looked at and have a look at what are the components that I'm actually using now, without going into all of the actual audio components. I want to look at, here we go, what we actually need in this case to generate that sort of conversational flow. And then I'll jump over to the little demo that I've started building, and we can continue building it together to understand where it's at. And I can't see the questions. So if anyone has any questions as we're going along, please feel free to call out and ask, why do you do that? Is there a better way of doing this or whatnot? And let's answer it as we go, as opposed to just showing you and confusing you. So if you do get confused or you want some extra clarification, just call out. So in this demo that I'm going to show you, the demo that I just showed you is called, I've called it Lex Audio, because I'm handling both audio controller and conversation. And then the session information is basically starting the Lex. So when Matt logged into the console and he's gone into the Lex bot and then he's doing the test, all of that session information is already there because we're inside the bot. So we know what bot it is. We know what version we're running. We know all of these session information by default. However, when we start a user interface, so when we're actually creating our own custom user interface to interact with Lex, we now actually need to tell the Lex endpoint, well, this is the bot name that we're going to be communicating with. So we have a bot name. We then have the bot alias for different alias versions, and then the user ID. So this will provide some session level information to link, say, the data that we've already recovered from the customer or from the user into maybe multiple sets. So like a welcome back. So if I go away, I come back, it might say, welcome back, Aaron. Last time you ordered an extra large men's black t-shirt. Would you like to order another, or would you like to order something else? Yeah. So we can now tie together previous session data with new session data by either storing a local session ID and linking it to the one that's stored on the back end, or generating a new one for a new customer. So that we'll get into a little bit more later. But for now, the two most important parts are obviously the bot name and also the bot alias, which is our version of the bot. By default, I just use latest because I want to use the latest iteration of our bot. So that's the information that's in the console, right? So that's the easy bit. What we want to do then is actually, so if we go back over to here, forgetting about audio control is the conversation. I wanted to show you the more complex side of it so you understand where I'm coming from. But then what we're going to do is we'll jump into our little demo and we'll just look at it from a text-based point of view only. We're not going to look at waiting for the microphone, waiting for a silence to know when to stop the microphone, or starting the microphone so that we can take an incoming audio and convert it into text so that we can send it off to the bot and so on. So that's essentially what I'm doing here. Is I am taking what we call our conversation class. I'm taking the configuration, so that the configuration is essentially the bare minimum of what we need to send the Lex endpoint to understand how to elicit a response, or how to actually generate a response. So let's quickly jump down to that. Apply default. So here we can.
And we did have a question. I was just going to say, we did have a question from Mickey Monkey on how does Dynamo fit into the equation?
Yeah, okay, good question. So let me jump over to session here, right? So this user ID, let's just say in my demo before, I've said, would you like to remember your details? Yep. So remember in the last session we had with Matt, or if you weren't in the last session with Matt took us through integrating a Lambda with the Lex bot and using that Lambda to validate the inputs that's coming from Lex into the Lambda. We can then use that same Lambda to then hand off data into a DynamoDB. So we can actually it's like a persisted session, right? So we're creating a profile, or you can even log the entire transcript or whatever data you want to store from that conversational flow into a DynamoDB, which will persist the session. And what I mean by that is Lex communication, so when you're talking with a Lex bot, is limited to a session, which means once that session expires, all of the data slots are scrubbed. So any information like my name is Aaron, Victoria 3000, all of that information, if I was to come back and say, what is my name? It's not going to know that your name is Aaron because the session is ended. And so you can see, probably that's exactly what's gone here. I'd probably need to refresh, but you can see it doesn't know how to respond because it's lost the session. So it's scrubbed all of the backend data for the slots. Yeah. So that's where DynamoDB comes in, is you can handle all of those slot data. You can actually send a lot more than just the data slots within the, let me see if I've got it in this demo, within the object that we send, content type user accept, no. So within the object, so this object here that we're looking at right on the screen now, we can actually send variables. So we can load up additional variables that we want the Lexbot to know about, which could actually be contextual, like what browser is the user using, or if we've done some sort of geo lookup and understand, where the customer is geographically, we might say, this customer is coming from North America, or this customer is coming from Australia. We don't specifically need to ask the customer that information, So we can hand that off in variables in the config as part of the object that we send back to Lex. And then that information can actually be validated through the Lambda and then stored in the DynamoDB, which then, if we have our user ID, all we need to do is, if we're using our user ID as the primary key on DynamoDB, is do a lookup on that user ID and say, hey, look, we've already got all these user values. So maybe if this user's coming back, instead of re-asking all the questions, let's just fill all the data slots that we already know about. So it'll do a lookup on DynamoDB. It might swap out a lot of those. So based on the intent that it's currently running from, it might fill some of the data slots that it already knows. And then it might also provide additional value or additional context to the conversation through those Lex variables. So that's essentially where DynamoDB would come in, is to extend the life of an individual conversation and session. I think that is probably the most basic integration with DynamoDB. We can get a lot more advanced, but I probably will leave it at that for now. And maybe we can look at integrating DynamoDB later, because in Matt's previous session, remember, he was talking about having the store, right? So having how many t-shirts we have, what are the t-shirt types, all of that stuff also needs to be stored somewhere. So that can be used also as DynamoDB. So now we have two different ways of interacting with DynamoDB, because now we're actually looking at fulfillment data. So I want an extra large men's black t-shirt. It's going to go off and query DynamoDB. Are there any in stock? No, there's not. It will know to elicit a response saying, apologies, but we're all out of extra large men's t-shirts, or black, or whatever it is specifically that they're out of. So there's two different ways of integrating with DynamoDB within the context of a Lex conversation. All right.
Yeah, I was going to say this all happens through that Lambda layer, right? So,
yeah.
In the very simple way, it's like your chat front end that's made in React to Lex, and then Lambda might do fulfillment, or it might do like a lookup of the product catalog. That Lambda integration to Dynamo we need to do, but the other thing that I used to do a lot of work around was actually customers would come back to the bot like 4 hours later. Like, I don't know if you guys are like me, but I have like 15 tabs open at one time, and I start doing one thing, and then something else urgent comes up, and then I switch over, and then I go back to my conversation, and by the time that I go back to the chat conversation, I might have actually ended the session with the chatbot, right? So if the only thing that you might tie to the front end is some form of caching of the session ID, so you can kind of re-raise it with the context.
So that actually, that raises a really good point. If, for those of you who were in one of the very first sessions that we started discussing Lex, I mentioned that there's two sort of different ways of doing the front end, right? So there's the way that I'm taking you through now is the more complex way, because I want to start complex and make it a lot more simpler. So when we get to the end, you've got a simple way of developing a UI for Lex. But if you start with complex, you know why we're moving to the simple. And the more simple way of doing that is actually offloading a lot of what we're looking at now into another Lambda that sits in front of Lex. So we can have an API gateway, which is a proxy to a Lambda, which does all the multi-way communication with Lex to handle maybe some of the data slot filling, maybe some of the context around the conversation. And then all we're doing from the front end is actually making a RESTful request, which might be post, so add the text, and it will send the text that you're sending. So my name is Aaron. And then it allows the Lambda from that API to then handle any communication with Lex and any response that it may already know, or it might do a query to the DynamoDB prior to handing it off to Lex. But then, to Matt's point, you have the integration with the Lex from the Lambda point of view from the back end. So now you've got Lex to Lambda, which is doing the validation of the current intent, and also might do additional queries. So there's two different points at which you can actually put logic, and depending on the complexity of your bot or the type of data that you're storing outside of the bot itself might depend on where you're actually querying that. So some of the profile data may be upfront, and then some of the like store and the actual fulfillment data might be up back. So by front and back, I mean in front of Lex and behind Lex, all still within the back end, integrating with the front end through a simple API. So then we just get to very simple post and maybe get. Like if it's just eliciting a response without posting, it's a get. Otherwise, post will send the text and wait for the response, and that's it. So now your UI becomes very simple, because all you have to consider is exactly what Matt said, is generating a unique ID, storing that within the session of the browser, so the browser session or even local storage, so it persists over sessions. And so when the customer comes back 4 days later, because they've been there before, you've got a local variable in local storage that is just a universal identifier, a GUID. And you just hand that off to the API, which can use that to then join all the profile information and join it together. Did you want to say something, Paul?
No, the only other thing that I was going to add to that is the only time that you might want a session ID outside of your particular browser or app is in the case where you've got prolonged conversations where the user might log in across multiple devices or multiple browsers. And in those cases, it forces you to get a little more complicated, where you might use like, Elasticache essentially, or, Redis, whatever under the hood of Elasticache.
Yeah, exactly. Absolutely. So let's move on from there. So I 100% agree. Like, there are multiple scenarios where you would tie a session or at least an ID to recognize who the customer is returning and whatnot into a bot. But in terms of stepping back to where we were and looking at sort of more of the complexity that we want to offload later, for now, what we're looking at on my screen is the actual underlying Lex object. So the object, which we call the Lex Config, that we send to the endpoint so that it knows what's the alias, like that's the stuff that we were looking at before in session, what's the alias and name of the bot that we're actually querying, but then we're actually looking at what's the content type of the request that we're sending, because you can send audio. Lex will handle the audio, or you may be sending the text. Yep. So we want to know, is it audio or is it text? User ID, any other additional variables that we want to provide, we can then provide through the Lex variables. What I will show you, I'm not going to show you the actual variables themselves, but the way that I manage this, obviously, there are other properties that we need to consider, and we'll get into that very soon when working with the AWS SDK, is, if you're doing through key and secret, then it's the key and secret and the region, as well as the language that you're working with. And then I think we can disregard these three here. The ones that are specific to Lex are just our key and secret, region, and language. And then the rest of that is generated when we, when we generated our conversation. So we're applying default. It's getting that Lex config, the beginning Lex config is coming from that, the session variables object that I just demonstrated there. Right, so the first thing we do is we construct that object, right? For a very complex conversation, we then have like states. So we start at an initialized state of passive, which means it's just waiting. We can go then from passive, if we're talking, to listening. So the Lex bot knows that somebody is talking into the microphone. Then the next state from listening will actually be awaiting silence. So it knows to stop listening and start processing. It will then do the sending. So that's sending it to Lex bot, and then it will do the speaking. Now, that's more advanced that I want to get into. So I'll very quickly jump into the demo that we're going to start putting together. But the one that I did want to look at finally before I jump over is eliciting the intent, right? So we want to know how to trigger off an intent so that's what is your command, right? The first thing that's doing is it's seeing that I've returned. So I, in the actual chatbot, have said, trigger my conversation elicit intent of initial, and it will fire off using this time it creates its own object instead of using the config object which we use throughout the conversation. And it says, all right, what's the bot name, the alias, the user ID, that's all the same. The dialogue action. So now we're telling it what is the action and intent that we want to fire off. And then the easy part and the bit that is probably the most important part is working with the actual Lex SDK. All we're doing is we're using the put session, and I'll jump up quickly to show you how we get to the Lex runtime, but we use the put session and we send that request as the body of that put session. And so that's basically the Lex endpoint is receiving this object, which says, go and find the bot by this name and version or alias, and go and action, or so trigger the dialogue on the intent that we're specifically looking to do. And then in this case, what I'm going to do there is, if it's successful, it's going to move to speaking, which means it's going to expect a response from that intent, and it will speak it out. It will also, it hands off on success the data, so we can display it in the text box. But I'm not going to demonstrate all that in code now, because we're going to start to mix between contexts and it'll be too confusing. So the last thing I'll show you here is basically working with AWS SDK. Now, there's two ways of working with Lex, and my preferred way, obviously, when working with Lex 2, is with the AWS SDK, because unfortunately at the moment, the Amplify SDK only supports Lex 1. So you can do a very simple interaction with Lex, and by simple interaction, I mean you can quickly make a chatbot as long as you're using Lex version 1 through the Amplify SDK, as well as there are existing Amplify UI components that have all of the chatbot and the send and everything hooked up for you. So all you really have to do is configure and point it to your endpoint, and the rest is done for you. So the reason I'm not using that is because we're using Lex version 2 for the Swag bot. And so we're going to use direct interaction with the AWS SDK. If you're doing it in Python, obviously it's Boto 3, and there is some great examples of developing a Python-based front end for Lex. I think probably the more common examples are all in Python, and they all use the Boto 3 library. All right, so from there, obviously you can see I've set some defaults. That's basically our sample rate for audio and obviously text when we're sending the text. Here we go. This is what I'm looking for. So from AWS, all we need to do is call the Lex runtime, and that will create the Lex object that we need, that then has all of the events and functions that we need for having our conversation with Lex. So let's jump out of this now and look at a less complex version of what I've started setting up, because I want to show you the breakdown of a complex UI, and then we'll use this app that I've created here. So you can see everything in yellow obviously is modified. Everything in green is what I've added. The rest that is white is essentially npx create React app. So it's a very simple React app. I haven't added anything as a main. I haven't even deleted the generic stuff that we don't need. And all I'm doing is I've brought over obviously our app config. We don't even need these guys. I've brought over our app config because we want to, for now, we might talk to the same Lex endpoint. So this is where we can specify, obviously, if you're running multiple environments, if you've got a alias for dev, an alias for UAT and whatnot, you would provide that through your environmental variables. And then also the same thing, you might have multiple accounts running different bots that you want to host your front-end UI across different accounts. So you can switch between using different bots in different accounts, or even different regions, or even different languages. All right, so from there, the two most important components, and now I'll get into the difference between before. Now all I'm looking at is conversation and session. Obviously, session will remain the same. The only thing that I've done is, instead of calling an external library of utils, which I had to generate my unique ID, is I've just brought that function in here because that's the only place that I'm using it at this stage. But this bot config remains the same. It's the object which tells us what's the name of the bot, what's the version, and our user ID. And then now you'll see a major difference between what we were looking at with the conversational flow. Now, it does have some of the components around the conversational flow in terms of passive and listening, because I do want to leave it there in terms of a conversational flow to show you how we can transition through states. If it was just passive and texting, it's not really transitioning, it's just send and receive. But essentially what we're doing here is we're applying the same logic as we did before. We're configuring our defaults, so we're getting that object which tells the UI or tells the actual the Lex endpoint which bot to trigger and the version or the alias. And then we're setting up our state change, which is basically when the state changes, whether we're sending, whether we're receiving, and whether it's successful or on error. And I've made this as an object so that I can extend outside of this object class into the chatbot. So I want to separate out what is Lex from what is chatbot. And the reason you might do that, or sorry, the chat box, the reason you might do that is because there's good reason for swapping between Lex or Alexa from a chat interface. Or what we're going to be doing is taking all of this Lex stuff that's in the UI here, moving that onto the back end, and then our chatbot still needs to function the same in terms of send and receive message, but now we're not going to handle everything in the back end through our Lex library. We're going to handle it just through a very simple service library that says send, receive, and update the chat box. So that's why we separate them out, keeping a separation of concern between logic and view. All right, so the states I said before, we have passive, listen, and texting. Essentially all we're doing, we're initializing our Lex runtime, so that's our library from the SDK. This time we're only specifying text, and we're going to initialize our state. So our current state not just our current state, but our multiple states are embedded objects within this object, right? So what I mean by that is they're separate classes which hold a state and a transition. So initial state is the current state that we hand in, and it's passive. We're just saying that the current state is passive, but then through our parent class, we can then activate the advance the conversation. So we want to go from initial to listening to know that we're ready to receive a question or an utterance. And then from listening, so that we do the same thing. Essentially, we're setting the state as was set up the top. Current state is now set to listening, and then listening will obviously have an advance at this stage of just going back to initial. So the only reason listening and initial are there, or listening is there at the moment, is to show you the transitioning between states for conversational design as opposed to the send and receive. The one that we're really interested in really for this demonstration is just texting. So ideally we could get rid of listening and we just have the difference between initial, which means that it may elicit a intent to get a response without sending text. And then from then on, it's just going to be texting, because it'll text and receive. So we're just basically allowing us to set within the conversational object what stage we're at within that. So through transition and advanced conversation is all we're doing. So the transition is basically we're saying, go to the next state, and essentially that will set the object ready for whether we're going to initialize a new conversation or text. Again, the most important one for this one is just send text. So this is exactly the same as what we were doing with eliciting an intent, but this time we're actually using that config object and adding additional information, which is our text. So the text that we add to our chat box will be added to the input stream of the Lex object, which then, in the same way that we did before, we're doing a post content, and we're just dropping that Lex object, so the entire Lex object, which contains all of the, let's go down and show you. So all of the information about what is the bot that we're using is sent in every transaction. So there is some level of state of the conversation stored within the actual conversation itself. And so the Lex bot itself knows how to handle, what is the current intent that we're working at, what data slot are we trying to fill or elicit a response to fill, and then whether we actually handed the whether there was an issue in processing, it will hand back an error. And if we do have an error, we obviously want to drop back to initial state instead of just crashing, but also we can hand out the error. So at this stage, I'm not really doing much with the error except filling it to an on error function, which you can then hand off to something else for logging or something like that. For texting, this is where we start to use our transition, right? So now we say we've sent text, so we know that we're in the state of texting, and we're handing the current state object as the class, then when we receive our data from our post content, we also want to hand it off to an onSuccess function. And that onSuccess function is the one that'll be the callback to then hand the message off to the actual chat box. All right, I think I've probably done a whole lot of talking, which has confused probably 90% of everyone on the channel. So if you've got any questions before I move on, please reach out now. And if I can explain anything in detail, we'll go through and do that before we actually look at, how do we actually start to use this conversation class as opposed to just using directly the AWS SDK and just doing a post content directly from our chat box.
I think the one question that's probably I'm going to preempt is, could we potentially put this on GitHub?
Yes, absolutely, I can do that. And I think it probably, as we progress through, because I realize I've done a whole lot of talking and not a lot of coding, and we're like 10 minutes until time. So probably I'll post it up to GitHub as it is, and so you can pull it down, you can play with it, you can mess around with it. As we add additional functions, I'll keep posting that up. But also, if you have any requests, or if you want to fix something, or if you want to just have a real play around, feel free to add pull requests and get us to have a look at it. And I'm happy to comment on your code and maybe even discuss why we do it one way over the other. Because there's no right way of doing it. This structure that I'm showing you now is based on my experience around conversational flow. If you're doing a very simple chatbot, then maybe it's going to be as simple as all you need to remember is the input and output of the actual post content in a state object, and then you might just repost that state object and change the input stream for the next one. So there are simpler ways of doing it, but I wanted to start complex to show you how we can start to integrate things like transcribing, so speech to text, and poly, which is text to speech, and other different integrations that we can do with Lex that enhance its capability. Which, obviously there is some level of language support as well in Lex, but then you can use our language API as well. So you can actually support translate. So you can have an entirely different language that your bot might be created in English, US English or AU English or EU English, and you're concerned that you might have Japanese or Chinese or other, actually I don't think all Chinese is supported through Translate yet, but you might have a language that's not supported in Lex, that is supported in Translate, that you can then translate into English, communicate with Lex, then hand the response back to Translate. And so the actual customer is communicating in their language, the one that they're comfortable with, but in the back end, it's still all English. So there are other interactions or integrations that make Lex a lot more powerful by using these atomic components to integrate with. And we handle a lot of those through whether it be the front end here, as I'm demonstrating, or whether we drop it behind the API and allow the API to just hand off a very simple post with some very simple information, like the language that I'm handing you is, simplified Chinese, and then yes, translate to English, and then it'll handle the rest of the integration from Lambda through the services into Lex. All right. So the simple answer to that, Matt, was yes. Okay, so I'm going to show you the quick integration. So now you have basically a high-level overview of the little functions or components required for integrating with Lex, in terms of understanding that we need to have our conversational object or our Lex object, which we then hand off to our post in our endpoint. The way that we can then use this, and through the separation of concern between the view or the chat box itself and the logic is, and this again is why I love using React, is our state management, right? So I can actually create the use state and say, like, this chatbot is going to store the message, and probably I might even go one step further and have another state object of transcript. So every time a new message is added to the message here, so instead of set message, we could use, there's two ways of doing this. Obviously, we could do set message and update transcript, or you could do, I can't remember what it's called now, but there's use resolve, I believe it's called, where instead of just using direct state to set message, you can actually set up additional logic within the resolve function. So instead of whatever you hand off to set message gets put into message, you might say, well, set message resolver will then update the message and also maybe update another state object as well. And that's your transcript. So now we're just adding to an array of objects. So you can see that I don't have the chatbot chat box there. And the reason behind that is because I didn't want to confuse the actual user interaction yet. So the actual typing into the text box, hitting the button. But I wanted to show you what are the functions that you need to actually get to that point. And so it's as simple as this, right? The first thing that we need to do is, remember I said we need our credentials. So that's our IAM key and our secret, which come from our app config, which are stored in our environmental variables. We're using, again, the AWS SDK to generate credentials based on, or the credentials object based on our key and secret. And that allows us to now interact with the LexBot, obviously, if we've set up a role for this user to interact with LexBot. So we obviously need to have an execution policy on the Lex side, on the backend side. And then we're setting up the region, which we're just pulling from our app config, which is also stored in our Lex object as well. I don't recall why I'm doing that at the moment. So I'll come back to that.
It's okay. I was going to say, Aaron, one of the group people think you've got a Kiwi accent, so you've obviously been spending way too much time around me.
It might be, yeah. It might be, I think, probably too much time meeting for devs in the shed rehearsals or discussions. I actually get that from, I spend a bit of time in the US, and I think people think that my Australian accent is being chiseled away by different East and West Coast accents. So I'm definitely not a New Zealander, nothing against New Zealanders, but I do have a very wacky accent. I understand it sometimes.
I put on my accent. I put an Australian accent in Australia, like, to fit in, and then when I go to the US, I put on a US accent. So that's part of the problem of switching countries so much. I agree.
So I've had a South African tell me that I sound New Zealand, and I've had a New Zealander tell me that I sound South African sometimes. I don't know, just probably spending too much time abroad. All right, so I've got 6 minutes left. I might wrap it up here, so I'm not actually going to get into doing any code as I had thought I would, but I want to fire off the most important part, right? So obviously, for those familiar with React, it's creating a React component is as simple as importing the class once you've exported it. So I'm using a functional class, so a functional component as opposed to a class component. Same. Whether you do a class or a functional component, you export it, and then obviously within a functional component, you'll be using use state, or use state and use effect. Whereas in a class component, you'd be using component did load, or I haven't used class components for a very long time, so I can't remember which ones have been depreciated and the like, but you've got your events in the life cycle of a component. So you're essentially just importing it. And at this stage, I'm giving it the name of the chatbot from the top level that I want it to use. So it's going to take that variable, create our Lex object from the Lex library that we created using the session. Remember, the session is the actual bot config. And I'm handing off the bot name, the alias, and the ID. I've lost it again, chat box over here. And so that creates our Lex config. So that's all the stuff that we want to send, or that's our object that we're sending to the conversation. So remember, when we initialize the conversation, a lot of the information that we need comes from config. So we take the information that we need that's not in the defaults. We then also apply the defaults to add to that additional information that we've handed in, and then we've got our Lex object that gets sent in every request. And then from there, it's as simple as we now have our conversational object, so we can now start stepping through transitions. In this case, it's very simple because all we're going to do is we're going to have a send text handler, which is going to be on our button for our chat box. You'll type in some text into an input, and then on the button, we're going to trigger off this send text, and the input value will be pulled from the input field or the input text. And then all we're doing is we're updating, updating the message state. So it's whatever the latest message is. And then we're actually using the conversation send text to send that off. So when we send that input value, remember, it's then taking the entire Lex object and sending it off to the endpoint, and then it's awaiting a response. So at the moment, the one thing that I haven't done here is I need to hook up the on success response. So what happens when conversation receives a response? I will add that here, and so then I can update the state of the transcript so that we can see it in the chat box. Or more likely, for a very simple chat box, I will just update the state of the response. So we'll have a message and response, and then we'll step through line by line and say, update the transcript with the response for this current line, and then we'll display the line. So I'm going to leave it at that for today. I think in the next session that we get into the UI, I'll leave it up to you guys whether you shout out whether you want us to, as I said, we're going to start simplifying it and dropping it back into having some of it separated behind an API and having it some in the UI. I can start that separation, or I can go through and show you the full working complex chatbot. So build out the chat box, add the final send and receive, and then updating the actual state to demonstrate the conversation as we did in the very beginning right here. And then once we've done that, then we can show how we break it down into the more simple RESTful send and receive. We've got 2 minutes, so I'm going to open it up to you, Matt and Paul, if there's anything else you want to add that we've seen, or anything that I can cover for next session that I haven't discussed at the moment.
Yeah, I was going to say PP5685 did ask when the next session is. Next week, we actually have on the calendar SageMaker pipelines, which is going to be really fun. And then what we'll see after that is probably the 27th of July. We always stream at 12 p.m. AEST time. So we keep the time of day consistent. So 12 p.m. AEST to whichever time zone you're in. But SageMaker pipelines next week. And I think we continue this the following week. Siobhan had some really good notes, like the best practices around React and moving away from component to mount, et cetera, et cetera. I completely agree. So, having use effect and React hooks would be kind of like the newest style or the newer approach. He did give us a little bit of a hint as to what it could potentially look like if we adapted this. But I think in 2 weeks' time, we'll continue the chatbot. We will write some actual code, hopefully integrate with the Lex backend that we've got from previous shows. And then probably in 4 weeks' time, I think we start to add the DynamoDB components and build out some of the use cases as well. And so hopefully within the next 4 or 5 weeks, we've polished off the chatbot and convinced marketing to let us order some swag so people can actually place orders, because that would be pretty cool. Anything to add, Aaron? Paul?
No, other than I think it's good as we've progressed through to see how we configure and build a chatbot, and we've got the test harness that does it. Taking that to production is always a bigger leap. It's all well and good to build a test harness for a chatbot. How do you go ahead and deploy that in a custom widget or whatever you're going to do on your specific website? It is a good thing to go into and to show how that's working. So yeah, it'll be good once we get that code up on GitHub. We can fix some of your use of var rather than let, for example. But yeah, I think that'll be good to start rolling that out.
Cool. Excellent. Well, I will catch everyone next week for SageMaker pipelines. Same time, same day. In Australia, it's our Wednesday, 12 p.m. AEST, but that converts to Tuesday sometime if you're joining from the US. I've got a hard stop, so I'll wrap up now. Thanks, everyone, for joining the stream, and we'll catch you all next week.
See you all. Bye.